Hi, class, and welcome to Chapter 1, Section 2 notes. We're talking about matter and change. So the first thing that I want to talk about is just what is chemistry? Okay, so chemistry is a physical science and the fact that we can physically do experiments to help us better understand what is going on. We have a nice big definition over it. Okay, study of study of composition and structure and properties of matter and the processes that matter undergoes. So the first part, again, is just some definitions. So we have the definition of mass. Okay, and remember with mass, we go to a balance on a scale. And then we have matter. So matter is anything that takes up a volume and has a mass. So since you take up a volume and have a mass, you are matter. Okay, so our next part is just the fundamentals, building blocks, and those are atoms and molecules. So what happens is atoms comprise or make up molecules, and those are made up of compounds. Okay, so the element goes to the atom, atoms form molecules, and molecules are compounds as well. We'll be talking about atoms. Okay, that's our smallest unit that maintain the identity. Elements, so pure substance that can't be broken down, and compounds, so it's one or more elements mixed together. A simple compound would be water. Molecule is the smallest unit that holds the properties of that chemical. So water, if you break it into H and O, it doesn't have the same properties as water. The same thing can be said for oxygen gas, which is O2. So what are properties that might help us? Well, there are two different types of properties. There's extensive properties, which has to do with an example or a sample. So volume, mass, amount of energy inside of a sample. So it's pertaining to one particular thing. Intensive is going to be pertaining to the identity of the chemical. So for example, all water has the same boiling point and melting point. It also has the same density and conducts electricity. So it brings us to two things. So a physical property, okay, is a characteristic obtained or measured without changing the identity of the substance. So we can determine the melting point of water without changing water or the identity of water. So it's not going to become a pancake. Same thing with boiling point. Now, a physical change is a change that there's no change in the identity. Okay. So if you take a piece of paper and you ripped it, it's still paper. It's two pieces now, but it's still the same paper. Same thing would happen if you take water and boil it. It's still the same water. Now it's just vapor inside your kitchen. So when physical changes a substance from one state to another. Okay, so for example, solid, that would be an indefinite or a definite shape and a definite volume. So what does definite mean? It means that it's a defined shape for a defined volume. Okay, it's going to have the same shape and volume, meaning if I had a block of wood, I know the shape and I know the volume at all times. Liquid, however, has a definite volume, but an indefinite shape. And the example is water. So a lot of you have water bottles, and they have the same amount of water in them, okay? But because the manufacturer makes their bottle look a little different, the water or the shape of that water is then different. So what we like to say is if it has indefinite shape, then it has the ability to take the shape of its container. Okay, so water takes the shape of its container. All liquids take the shape of their container. Gas, it's got an indefinite shape and an indefinite volume. So the example I like to use is what happens if someone passes gas. So if somebody farts, it takes up the volume eventually of the room and the shape of the room. So eventually it will take up the entire space that they are in. That brings us to chemical properties. So now, with chemical properties, we are talking about substances undergoing a change, and that change, okay, is like burning or rust. So once it happens, that makes a chemical change, and you cannot go back. So rust, you have iron plus oxygen becomes iron oxide, a form of iron oxide, and you cannot go backwards. Okay. In a chemical change or a chemical reaction, we have reactants. That's the thing that we start with, and then products, the things that form after the change. So down here we have carbon and oxygen. Okay, will make carbon dioxide. Or CO2 gas, this is a little bit more common for you guys, CO2 gas plus water liquid makes H2CO3, which is carbonic acid. And this is what happens anytime you guys go to fill up like a big gulp or a Polar Pop or anything like that. You're making carbonic acid in the form of a carbonated beverage. Okay. Reactants on the left, products on the right. So we had a nice little checkpoint. So go ahead and pause it and let me know which one or what you think for all of these. All right, welcome back. And tearing a sheet of paper, well, that's going to be a physical change. Melting a piece of wax, it's still wax, so it's physical. Burning a log, I cannot get the log back. So the question that I would ask is, can I get that log back? I can't, so it's a chemical change. If something has a fixed shape, what state of matter can it be? Well, fixed shape, it has to be solid. Fixed would be a definite shape. So definite or fixed. Now, if a sample has a volume that changes to fit the container, what is it in? What state of matter can you infer you are looking at? Well, I would say you're looking at a gas. And the reason you're looking at a gas is that if the volume changes to fit the container, it has to be gas. Because a definite volume is a liquid and a solid. We know those volumes. Moving on to the second portion of 1.2. Classifying matter. So matter can be classified into two things, and that is a mixture and a pure substance. So we have some mixtures here. Okay, we have some fruit salad, and we have some Rocky Road ice cream. A mixture is a blend of two or more types of matter, okay, that you can still identify as their own thing. So, for example, a homogeneous mixture is something that's unified. It's the same, okay? It's uniform in composition. It's the same throughout. We have a nickname for it, which is AKA a solution, okay? Kool-Aid is a great example of this. As long as you mix Kool-Aid according to the rules or its directions, it's a homogeneous mixture. Now, I know because I've done it. You mix it and you put a little too much sugar in there because it tastes even better, and then you get a lot of sugar at the bottom. That would not be homogeneous. But if everything's dissolved, it's homogeneous. Heterogeneous is not uniform throughout. The example would be like a chocolate chip cookie. Everybody has taken a bite out of a chocolate chip cookie, and there's only been one chocolate chip. And then there's a whole bunch of elsewhere. I like to also think of, hey, you know what? What about like a pepperoni pizza? You always have slices that have a whole bunch of pepperoni and some slices that don't. Ways that you can separate a mixture: you can filter it, you can decant it, you can use a centrifuge, which just spins it around really fast and puts the heavy stuff at the bottom and the light stuff up top. You can use chromatography, which allows liquid to run through it, and it separates it also. The one that has a lighter molar mass will move faster. The one with a heavier molar mass will move slower. And then magnetism. The cool thing with magnetism is you can actually crush up things that have iron in them. And if you crush it up and put a little bit of water in there, you can take a magnet and actually get the iron shavings out of stuff. Looks kind of cool, but you might not want to eat your cereal after you've done that. A pure substance. Well, a pure substance is going to be a fixed composition with the same characteristics. Underneath a pure substance, there are two different categories, and those are elements and compounds. So, for example, this would have distilled water in it. We would run some electric through it, and the electric would break it up into hydrogen and oxygen. So those would be pure substance elements. Here is a great flow chart for classifying matter. So matter, can it be separated? If it's a yes, it's a mixture. If it's a no, it's a pure substance. Then, once you get to mixtures, is it uniform in composition, or is the composition uniform? If it's yes, it's a homogeneous mixture. If it's a no, it is heterogeneous. And we have some examples. Granite, wood, and blood are heterogeneous. Homogeneous would be air, sugar, and water, and stainless steel. The other question you might ask for a pure substance is, can it be decomposed by ordinary chemical means? If it's yes, it's a compound like water, or sodium chloride, or sucrose, aka table sugar. If it's not able to be decomposed, it's an element because it's already at its smallest form. So gold, aluminum, oxygen, and chlorine. Later on in the week, we'll be doing a mixture versus pure substance activity, and you'll just get on there and follow the directions on the worksheet. All right, if you have any questions, go ahead and let me know. I will let you know that right now, this chart right here on the last slide will be extremely helpful if you ever find yourself stuck wondering what a item or a substance is. All right. Hey, I hope you enjoyed it. And I'll be back with chapter 1.3.